good morning to one and all. Today's our goal is force chapter and this is the second chapter. So let's start. Right, first question. A force F acts on a stationary body for the time t. The distance covered by the body S will be proportional to. We know very well S is equal to ut plus half at square. Here this force is constant force. The force is constant force. And stationary body means initial velocity equal to 0. So then S is equal to, in the place of u 0, that is equal to half at square. We know very well here force is constant. According to Newton's second law of motion, in the place of F we can write ma is equal to constant. So if m means mass is constant. So A is constant. A means acceleration. Here acceleration is constant. Force is constant means acceleration is constant. And 1 by 2 is constant, A is constant. If you remove equal and constant, we can write S proportional to T square. So here S is distance. So the distance covered by the body S will be proportional to T square. S will be proportional to T square. So option 3 is the right answer. Next here, second question. An external influence which changes or tends to change the state of rest or uniform motion of body or its dimensions is called an external influence which changes the state that is nothing but force. So option 2 is the right answer. Next here, third question. If a body is allowed to freely fall from a height, its speed increases continuously. It is because, so when a body is allowed to fall freely, suppose initial speed equal to 0. So because of acceleration due to gravity and because of gravitational force, its speed increases. That means it is because gravitational force of Earth increases its speed. So option 3 is the right answer. Next here, fourth question. An 8,000 kg engine pulls a train of 5 wagons, each of 2,000 kg along a horizontal track. If the engine exerts a force of 40,000 Newton and track offers a friction of 5,000 Newton, then the net accelerating force acting on the system is. Here, this is the engine. This engine is pulling a train of 5 wagons. Here 5 wagons. Each mass is 2000 kg into 5. This engine exerts a force of 40,000 Newton. And here this track, here this is a track. This track offers a friction of 5,000 Newton. The net force means this engine exerting force, that is 40,000 Newton minus 5,000 Newton, that is equal to 35,000 Newton. This is the net accelerating force acting on the system. So option 2 is the right answer. Next, fifth question. Right. Which of the following contact force situation involves a non-contact force? Here this is the wrong. Which of the following situations involves a non-contact force? According to in your syllabus, so give examples for non-contact forces. Yes, that is gravitational force, magnetic force and electrostatic force. So opening a drawer means here contact is there. Kicking a ball, contact is there. Closing a door, contact is there. Here this magnetic pulling an iron piece without physical contact. The magnet pulls iron piece, so it is a non-contact force. So option 3 is the right answer. Next here, sixth question. Which of the following statement is not correct for an object moving along a straight path in an accelerated motion? Their object is moving along a straight path and it is an accelerated motion. Suppose initially its speed is 5 meters per second. Here direction is not changing. Accelerated motion means its speed should change, that is 10 meters per second, next 15 meters per second. That means here speed is changing here. If speed changes, velocity changes. So speed keeps changing, right answer. Velocity always is right answer. It always goes away from the earth. It always goes away from the earth and a force is always acting on it. Not correct. Not correct means here, well, speed is changing means force is acting, velocity changing, speed keeping. It always goes away from the earth. No. Suppose if the object is moving towards the center of the earth also, its speed increases because initially its speed is 0, but due to gravitational force of earth, its speed increases. Its speed increases means it is an accelerated motion. So option 3 is a wrong answer because it always goes away. No, if it goes towards the center of the earth also, it is possible. So option 3 is the wrong answer. Next, seventh question. Here, seventh question. An object of mass 2 kg is sliding with a constant velocity of 4 meters per second on a frictionless horizontal table. The force required to keep the object moving with the same velocity. My dear children, constant velocity means acceleration is 0. If acceleration is 0, already we know very well, net force equal to mass into net acceleration. If net acceleration is 0, net force is equal to 0. So the force required to keep the object with the same velocity is 0 Newton. It is according to Newton's first law of motion. Next here, eighth question. An object moving at constant velocity. An object moving at constant velocity must. Constant velocity means net acceleration equal to 0. Must have net force on it? No. Eventually stop due to gravity. Not have any force of gravity on it. Have 0 net force on it. Here, eighth question. Net acceleration is 0 means definitely net force should be 0. So have 0 net force on it. Option 4 is the right answer. Next here, ninth question. When balanced forces act on a body, when balanced forces means net force is equal to 0. Here balanced forces means two forces are acting along same straight line in opposite direction. The net force equal to 0. It is related to first law of motion. First law of motion, that is, must remain in its state of rest, must continue move with uniform velocity if already in a motion. So two statements are correct. So option 3 is the right answer. Next here, 10th question. A force of 100 Newton acts on a ball moving on a surface. The force of friction that must act between the surface of the ball and the surface so that ball keeps on moving with constant velocity. Here, a force of 100 Newton acts on a ball moving on a surface. This surface exerts a frictional force. Okay, but the ball is moving with constant velocity. The ball is moving with constant velocity. Constant velocity means net acceleration is equal to 0. Net acceleration equal to 0 means net force equal to 0. That means the force of friction should balance this 100 Newton. That means the force of friction also 100 Newton. So option 1 is the right answer. 11th question. If an unbalanced force applies on an object, then the object. Here, my dear children, unbalanced force. Unbalanced force means net force is not equal to 0. If net force is not equal to 0, net acceleration also not equal to 0. So the object moves with some acceleration. Next, 12th question. Here, the inertia of an object tends to cause the object. Here, inertia means unwilling to change its present state. That means it resists any change in its state of motion. So, option 3 is the right answer. Next, 13th question. Here, my dear children, 13th one is very important question. Look at the screen. A passenger sitting in a train with his face in the direction of a moving train tosses a coin which falls behind him. It means that the motion of the train is. Here, a passenger sitting in a train. Okay, this is the coin. Suppose the train is moving with a speed of 5 meters per second. Here, the coin is in contact with the passenger. So, the coin speed is also 5 meters per second with respect to a person and ground. Here, there is no relative motion. There is no relative motion between coin and the passenger. Here, my dear children. Next year, when the passenger tosses a coin, okay, tosses a coin means the coin loses the contact of the passenger. The coin loses the contact of the passenger, but already the coin speed is 5 meters per second in the forward direction. That means the coin moves 5 meters per second in the forward direction. But my dear children, the coin falls behind him. Suppose when he tosses the coin, immediately the train moves a speed of 10 meters per second. That means in 1 second, the passenger covered, in 1 second, the passenger covered 10 meters. But in same 1 second, the coin covered a distance of 5 meters. That's why only the coin falls behind the passenger. When it is possible, means the motion of the train is accelerated. The motion of the train is accelerated. Because here the train is accelerating. In 1 second, it covers more distance. That's when the coin falls behind the passenger. So option 1 is the right answer. Next here, 14th one. A water tanker filled up to 2 by third of its height is moving with a uniform speed. Here it is a water tanker filled up to 2 by 3 of height h. Okay, total height is h, 2 by 3, and is moving with a uniform speed v. On sudden application of the brake, the water in the tank, on sudden application of brake. Here, my dear children, this is the lower contact. So when sudden application of brakes, the lower part is in contact with the tanker. So it shares the motion. But suddenly the upper part does not share this motion. So initially it is moving with a speed of v in the forward direction. So the lower body comes to rest. But the upper body continues its motion due to inertia of motion. Because the upper part does not share the motion immediately, it continues in its motion. That's where the upper part of the body moves with a speed v in the forward direction. Due to this, the water in the tank would move forward. So option 3 is the right answer. Next, 15th one. 15th question. Suppose you are traveling in a high-speed train like Jan Shatabdi Express, which is traveling with a uniform velocity. If you flip a coin as shown in the figure, you will observe that. You will observe that. This is very easy question. Here initially the coin is in contact with the passenger. Suppose the train is moving with a speed of 5 meter per second. So man speed is also 5 meter per second. Coin speed is also 5 meter per second. Here my dear children, here after some time he releases. He simply the passenger flip a coin like this. See, this is the flipping. So flipping a coin, okay. But already we know very well the train is moving with uniform velocity. Uniform velocity means again here the passenger speed is 5 meter per second. The coin speed is also 5 meter per second in the horizontal direction. So the coin again comes because its speed is 5 meter per second in the horizontal direction. The coin again falls. The coin reaches again in the hand of the passenger because his speed and coin speed in the horizontal direction remains the same. So in 1 second, the passenger moves 5 meter. The coin also moves in 1 second, same 5 meter in the horizontal direction. That's why the coin reaches again in the hand. So this due to inertia of motion. 15th one is second option. Next, 16th question. If the train is retarding, then you will observe that. In the same question, the initial speed of the passenger is 5 meter per second and the coin speed is also 5 meter per second. Here when the coin releases from the passenger's hand, its speed is 5 meters per second in the horizontal direction. But this time the train is retarding. The train is retarding means no, the speed of the train is 3 meters per second. That means in 1 second it covers only 3 meters. But in 1 second the coin covers 5 meters. So this time the coin falls in front of the passenger. So option 3 is the right answer. Next, 17th one. The magnitude of inertia of a body is determined by its. Here inertia of body is determined by its mass. More the mass, more is the inertia. Greater the mass, greater is the inertia. So option 2 is the right answer. Let's go to 18th question. Here 18th question. There is a rubber ball and a stone ball of same size. If both balls are at rest, which has more inertia? Here rubber ball and stone ball. Rubber ball and a stone ball. Is a stone, it's a rubber ball. Same size, that means same volume. Both balls are at rest means initial velocity is 0. We know very well stone has more mass. So greater the mass, greater is the inertia. So stone ball has more inertia than rubber ball. So option 2 is the right answer. Let's go to 19th question. When we vigorously means suddenly shake a branch of tree. Vigorously means rapidly. If you are shaking a branch of a tree, some leaves get detached. It is due to here the branch and here leaves. Initially the leaves are at rest. When we vigorously shaking, what happens? The branches are come to in rest. So initially they are at rest, the branches are come to into motion. But this motion is not shared by the leaves because sudden motions are not shared. So this motion is not shared by the leaves. Initially they are at rest. It maintains its inertia of rest. That's why the leaves are detached. It is due to inertia of rest. Next, go to 20th question. When a speeding car takes a sharp turn, then the person sitting in it experiences outward pull. This happens due to. Here, so when a speeding car suddenly takes a sharp turn, then initially the person is moving in the straight line. When the car takes a sharp turn, he wants to maintain his motion. When a circular turn is there, we know very well, centripetal force comes into motion, centripetal force comes into action. The centripetal force acts toward the center of the circle, but the passenger in a passenger will experience a centrifugal force in the outward direction. In outward direction. This is due to change in its direction. But actually he want to maintain his own direction. That is due to inertia of direction. So option 1 is the